So as I was already showing you how to laser scan objects with the EinScan HX, I am going to present you as well the rapid scan. So rapid scan is like laser scan, just another menu. You have here your history bar that shows you where you are, when you did your last calibration, what is your device that you are using. You should turn it on at least. Okay. And right now we can work. We are going to use the rapid scan, and basically it's not so different from what you already know from the laser scanner. You have to choose if you want to continue a project that you already did or a new one. We are starting a new one. I already gave it a name. It's rapid. Yes, we will replace that folder because it's already there. You have here some more choices, or let's say different choices as well from the laser scanner. We have the non-texture, just geometry scan option. That means we are technically scanning like just geometry, or we can do texture scans. That means additionally to the geometry there will be captured the surface color information. It's just a surface color information in a diffuse channel. For the more advanced people, this is quite common for normal scanners that we can buy today as hand scanners. That means there is just like JPEG pictures shot during the scan, and they are mapped on the geometry. Normally I'm just scanning geometry with the scanner, but in this case we can do a texture scan. That means we have additionally to the geometrical information the information of the surface color. Okay, so alignment is a very important topic. Here is the several different possibilities how to do the alignment. What does it mean, alignment in general? Imagine that 3D scanner is shooting in each frame, it's shooting like a shell. Imagine it that you have for example an egg, and if you break it into pieces, of course in the scanner it's all of these pieces have to have overlapping. They are stitched together, and stitched together each of these shells that you are shooting as a 3D picture, let's name it like this, is giving you in the end a volume, body or a complex surface that you can use for your technical purpose. So the scanner is just shooting that single shells. They can have different shapes regarding your objects that you are, the object that you are shooting, and of course that scanner is operating in some digital environment, and you have to know where to put the scan. It means he is having some data room that's consisting of points, and you have to know the points that he created where they are relatively to the next ones. For example, if you are shooting coming back to some surface, he's patching together scan by scan with the overlapping that he is having different surfaces, and in the end the sum of the surfaces that's in itself again consisting of points. This is your model that you will receive in the end. So to know where to put that new scan, the next frame, the next and the next frame too, you have different possibilities that you can use to give him that orientation. First is markers. As you can see, markers on the part here itself, they have a function similar to the stars in the sky, for example for a sailor that's orientating himself on them in the night, and that scanner can see that markers, and he knows the first side where they are. He's memorizing where they are, and he's meanwhile capturing geometry, and this geometry is aligned relatively to the marker. So each shot he will do on new markers, he will position it to the existing ones that he already have seen before, and so he is able to locate the destination of that shells that he's shooting. Then we have features. That means features is like surface curvature changes, geometries. He will see in one shell, for example, parts of the ribs, and they will be again in the next one partly, and he can use them to superposition two shells that he shot. So he have this part of the outside surface, the next one have some overlapping, next one having overlapping, and like this he is capable just using the geometry to continue that part. Like it's some process that's serially working, and he's in the end having all that model in this way created. There is hybrid alignment. That means he's using the first two options together. If he is not seeing any markers, he is using surface features, surface geometry. So you have actually a more secure alignment, and I prefer this one for technical scans only. And there is a texture scan alignment helps. That means if there is, for example, like on this paper here is some texture like writings, he's using the writings to orientate himself as well to additionally get better alignment. Where this is an extreme example, for example, imagine you have a plastic ball, a football for children, and this ball is just white. And imagine you are a scanner, you don't know anything about the world, you shoot the first picture of that sphere, but that sphere from each angle of view is having the same kind of the shape because there is no geometrical features, no curvature change. So how do you shoot the next picture and align them together? It's impossible, because if that ball sphere is really good in the shape, nearly perfect in some tolerance, that scanner have absolutely no orientation. If you would have a textured ball, for example, you have the same plastic ball with the picture of a soccer player like, I don't know, Cristiano Ronaldo or anybody else you like. He's able to shoot that part of a sphere that will be like an eggshell from a broken egg. Of course, in this case, it's just a sphere piece. He will see that, okay, this is, for example, part of the face, and he will in the next one see part of the face and the neck, and that he will be able by the texture as well orientate himself. He can separate the different orientations of that ball, and he can relatively to that positions that he shot make a model. So this is the idea behind using texture for alignment. There is advantages, disadvantages. Maybe I'm going to do a separate video on the different alignment modes and what it means in the practice. I'm just, let's say in this case, using hybrid mode because it's really stable, and I don't want to continue too long on that topic. It's actually a topic that have a lot of details to think about it. Next one, you already know it. There is resolution, there is some standard values that you can choose. You will already see that the maximum or the highest resolution in the rapid scan is not the same like in the laser scanner. The laser scanner is having 0.05 as maximum resolution, what is a really high, good value for a scanner in that price class. And yes, it's rapid scan, and that's why it's maybe as well not needed. And yes, we will pick up some value that's reasonable, that will give us a good impression. I think in the laser scanner example I was using 0.2, doesn't matter. This is very high detailed information. Okay, so global markers. This is just to speak shortly about it. It's not going to be so important for nearly the majority of the users. You can import markers positions, for example, from a photogrammetry system. It means you are importing from an airplane, for example, marker positions that are there. And if you want to scan something at the tail and for example the cowling in the front where there is the motor. You can, without scanning the whole airplane, scan both of them and they will be aligned by this markers that were pre-scanned in some other way. Or you can pre-scan as well with the EinScan itself, just some markers without geometry, and import them as well. Okay, so we will start the project. Nothing really special. You will see that the control panel looks a bit different from what you've seen before. And the laser scanner project group is quite clear. It's like views of the object, nothing really different. In the end, you will have views scanned one time by laser. This time it's over LED projection. So let's start with, I don't know, downside, like its position. We go back. Here is 2 bars. The first one is to adjust the brightness, but it's possible as well to do this on the back side of the scanner itself, as in the laser scanning already mentioned. LED brightness as well in texture scanning. Then there's plane detection for base plane. We have a table here, so it's fine to keep it on. And texture flashing is mean there is on the scanner itself, there is different LEDs. You can see them if you will activate the scanner. And they are helping you, like in a flash from a mobile phone, to shoot the color of the surface if it's darker. And yes, we will use them because here in this room it's not making any sense to try to do it without. So we are ready for the first scan. We have the downside, like explained in the laser scanning example. There is enough markers, or at least there should be. Some of them are on the part, some of them on the improvised turntable. And let's start scanning. Going to push the button on the scanner. I have to maybe adjust the brightness. You will see in the preview what the scanner would capture in this case. You see that in the left side, the distance. If I'm going with the brightness up, if it's getting more visible or less. Okay, we are already in the preview on the left side from the camera. We are quite having big red surfaces, so we are a bit too bright. Okay. It's fine, I think. So we can start the scanning. Right now you might see that there is patterns projected on that surface from the part. And that camera is detecting that patterns, and like this there is generated some surface. You will already see in the preview that there is information, texture information. That means the sticker kit that I'm using for rotating is having color on it, and this is already captured as well as texture. Just in this moment I'm not having too many markers visible. Okay, no problem. Going a bit more straight up. Right now I see a lot of red dots. That means a lot of markers. And closer to the object now. Don't forget, if you go closer, turn down the brightness, because it's less light that's getting lost during the scan process. And like this I can turn the motor like in the laser scanner and be fine. Okay, so this is some first view that we created from the inside of the motor. You see that there is texture and that there is geometry as well. As I'm, let's say, scanning in a not changed environment, I can continue scanning as well. I can turn on the scanner again, and you see over the tracking points you can find its position. So just keep in mind, you have to sometimes change the view, but just if you are start to reposition the markers relatively to your object. That can mean two things: that you are changing the marker's positions on the object itself, or if you are using some environmental markers like on a turntable, or in this case on the foil, they shouldn't as well not be moved. If I would move the part itself to the underground, it will be a problem as well because of marker positions that will change. But as I didn't do it, I can continue scanning with pauses, no problem. I will be always capable to scan the same things continuing, so I can make a pause, get myself some coffee, whatever, continue scanning, and it should be fine. Yes, you see already that here capturing some polished areas is not perfect. I'm not going to continue that scan because I don't want to continue using the texture, just for show you how it looks. And if you will leave the preview mode, for sure you will get some better quality already. It will improve over the steps. And this is some preview of what you scan from the inside. I would have to do the same 3 views, outside, inside, and some at least one side standard version like in the laser scanner, and I will have some nearly complete geometry for getting a volume. As it is the same like in the laser scanning, I'm not going to do all of them and speak about it more detailed. I just want to go back and show you, for example, the scan without the texture. Yes, click the scan. Again, rapid scan. Yeah, let's delete the existing project. We will say that we will delete it. Just keep in mind, start a new project, always create a new folder. This is avoiding that you are overwriting without wanting your existing results that you already created. And you don't need to save the scan during the process because it's actually done automatically. This is like a data bank saving that you don't have to manually do it. It will be done automatically. So if you will open, for example, the folder structure, meanwhile you are scanning, you can see that that information is saved there synchronously, so you don't have to be worried about it. As I was creating in the laser scan that environment marker here in the end for the side view, I see that they are not enough for this flat view where I'm looking, for example, from upside or downside. It's important that you always see enough markers. So I'm going to put there some additional ones right now. I'm going to not do a texture scan. I will use hybrid alignment, detail, so it doesn't make such a difference. Just for showing you how is the difference right now. If you start to capture, you just already see in the beginning that there is projection, and we start capturing, and starting capturing, you see that there is no texture information that's captured. Just right now doing one turn, let's see if we get better scanning results using higher brightness. Yeah, you can see that the paper is overbrighted, but inside the picture is getting a bit better. Maybe this is already too much brightness, but it's fine. So you can use that buttons on the scanner itself for adjusting the brightness, and like in the laser scanning, you have here the additional buttons for the zoom. Zoom means zooming in and out the view in your project, not real zoom in the scanner itself. It doesn't change anything physically in the scanner or in the way how it is working. I just see more what is important to me. So let's capture a bit more details from inside. Okay, as well, not going to finish that whole project here. You see that, okay, there is missing quite a lot on the top. So you have to get different angles. What we did right now is to get more ones. And like in the laser scanner, you have to be really sure that in different angles of the scanner there is always markers visible for the scanner itself. That they are visible for you as well in the preview. It's not necessarily mean that the scanner can see them. He is just able to see markers in a different range of angle to the surface, and you will see that in the preview. You will get some feeling for that, no problem. So this is the pre-result from the first, let's say, geometry scan. You can already see that there is some differences to the laser scan, but if you will train a little bit, spray the surface with some 3D scanning spray, that results will look much better and really great and good enough for a lot of things actually. So this is mainly the rapid scan mode. Of course, everything else that comes afterwards is again the same. If you create views over laser scan and over a rapid scan, it doesn't make a difference. You afterwards go to the alignment if you have a top and a downside and the side that you capture, like in the laser scanner, from 90 degrees turned, and you merge them and create a STL model also. What else? What is to be mentioned is that so far it's not possible to combine created views, means project groups like this one, from the laser scanner with the rapid scan. As I was hearing, this is planned that this will come, but it's not like that so far. You can go over Geomagic Essentials or some other third-party software, but in this moment you will receive the Geomagic with the scanner itself, so it's for you free of charge if you already bought or purchased the scanner, and you can combine them in there. I think the rapid scan is a really cool feature. For big surfaces, you will see that for organic surfaces like body parts or so, or as well as surfaces with a tissue or so, it's really great to capture fast. That the laser will take you more time because of different way how data is processed in the laser scanner mode. Just in the laser areas data is acquired, of course a lot of that, but it's different in the projection. You have a lot of more areas that in same time can be recognized over the scanner. Yeah, that's it so far. Next topic will be merging scan views to succeed to make a full watertight model, and yeah, see you there.